This is a look at the just completed Harry Miller Miller-Goosen style double overhead cam conversion of what was originally a flathead V-12 Packard. This engine was done in the style so well honed by Goosen and Harry Miller, and then Fred Offenhauser, who was Miller's shop foreman in the 1930s, 20s and 30s. And then Fred took over the business after Harry Miller's bankruptcy, and Randy Offenhauser engineering until the end of World War II, when he sold the business to Louis Meyer and Dale Drake, and they continued with it until Louis Meyer left in the mid-60s for a better offer from Ford, and Drake continued on through his son John Drake into the very early 1980s. The last business that I did with them was in 1982 when Hans Hermann designed an intake camshaft for me for my last offie effort at the Indianapolis Motor Speedway in 1982, which is the yellow car in the picture on the wall. That was probably the last competitive offie effort to run in the 500. Unfortunately, that chassis started out as a 1976 Lightning, so it was pretty obsolete by 1982, even with the addition of a ground effects body on it. But to get to the engine, the Harry Miller design philosophy, which he's really noted for. Harry Miller's engines have a particular look. It's a very Art Deco look, and all of his engines had that exact same appeal. They were all very similar. Of course, they were all, or mostly, engines were drawn by Miller-Goosen, Harry's draftsman, going all the way back. And Leo stuck with this design philosophy all the way through 1974, while he was still working on updating the last of the Offenhauser 4 cylinders to a 19-degree narrow valve version. And when Leo passed, the drawings were touched up and finished by Hans Hermann, who was imported from Germany to try to complete Leo's work. And Hans Hermann, of course, went on to design the unsuccessful DT-160 Drake V8. But the 19-degree offie was a good engine. This engine takes its cues from the narrow valve offie. So let's take a look at the history of the Miller engines and why they were designed the way they were. The first thing that comes to mind is that probably the most important milestone engine of all time was the Peugeot that was brought to the United States in the early 1910s, 1912, I believe it ran for the first time. The Peugeot was designed by Ernest Henry, the great Swiss designer. Ernest Henry is the guy who invented this direct cam over bucket, 4-valve per cylinder, double overhead cam 110 years ago. And his design has stood up. Racing engines are still designed like that today. A remarkable feat of engineering. And the Peugeot came here and raced successfully. It eventually wore out and blew up. And since France at that time, by 1914, was heavily involved in World War I, someone had to step in and make repair parts for the Peugeot engine, and so that job fell to Harry Miller, who was building carburetors in California. And Miller absorbed the design from the Ernest Henry design and began to produce his own line of engines, including supercharged small displacement straight 8s and a couple of V8s, a couple of V16s, W engines. He used this configuration in every displacement, in every size, all very similar to one another. The one thing you'll notice from the earlier Harry Miller stuff is this valve angle. And the early Miller engines had an included angle of about 90 degrees between the intake valve center line and the exhaust valve center line. And so about 45 degrees per bank, which spread the camshafts out significantly. And that was done back before valve springs were particularly good. And the secret in that era to make the engines breathe was to unshroud the valves as much as possible. And that was done by the wide valve angle, which allowed the valves to move away from the side of the cylinder wall as they opened for a maximum unshrouding effect. However, the wide angle also necessitates the idea of using a high dome piston. And the high dome piston would then slow the flame front in the engine and therefore slow the combustion rate. Would need a lot of ignition advance to make it work, and ultimately the engines would run out of RPM because of valve spring problems above 6,000 RPM or so. Then as the decades went by, it was determined, and especially notably by Art Sparks, who was another one of the Miller crowd, who used some of Miller parts. Of course, Sparks designed his own engines, but a lot of the parts were machined by Fred Offenhauser in Miller's shop. Sparks had his own shop, but he also had parts made at Offenhauser's shop simply because Fred could get the stuff out the door quickly. And Sparks had several innovations. He's noted for the forged racing piston, which he developed using surplus aircraft presses from use in World War II. He was able to forge aluminum pistons. He also, less widely known, was known for his valve springs, S&W valve springs, Sparks and Witherington, and those were the first double vacuum melt steel valve springs. And Sparks had concentrated on valve springs since his great failure of his Big Six supercharged six-cylinder engine leading the 500, relying on Buick Roadmaster valve springs, which failed him. And so he decided that valve spring technology really needed to be worked on. Art Sparks isn't credited enough for his contributions from forged aluminum pistons to DVM valve springs. The thing that's most important is that once the valve spring technology began to improve, Art Sparks was also the guy who went to Europe and came back with the idea for the narrow valve offie, which was first at 22 degrees. Each intake and exhaust was 22 degrees from the vertical, and therefore a 44 degree included angle. And that engine was known as the DGS, or Drake-Goosen Sparks. And it was run successfully, particularly by Patrick Racing and George Bignotti in the mid-70s. Won a lot of races with the DGS. The 19 degree offie, which was slightly narrower still, 19 and 19, or 36 degree included angle. That engine was started by Leo Goosen and finished by Hans Hermann, and became the last of the four-cylinder offies. And those are the last engines that I particularly worked on and built. Here's a picture of me, second from the left on the bottom row, working on a 19 degree offie with Marvin Clifton and Bob Soule. And I believe that would be the 1981 Indianapolis 500 in the garage area. The Cosworth DFX, which came over from England, originally as the DFV, was turbocharged by American Parnelli Jones Racing. in California, but when it was originally designed, it was also a narrow angle engine, 16 degrees per valve angle, or 32 degrees included, and ultimately that kept being narrowed until the Ilmor A of the late 1980s came along and utilized a 10 degree intake and 12 degree exhaust to get the flattest possible combustion chamber for very rapid flame travel. And of course the Ilmor A was an incredible, groundbreaking engine, starting Ilmor's long career, building winning Indy 500 engines and some Formula One stuff. Now this particular engine, I designed it for a 12 and 17 degree valve angle, 12 degree intake and 17 degree exhaust, which fits nicely on the very small bore. Being a V12, it has bores in the 3-inch range, and it allows for a nice flatter combustion chamber, and of course it's also suitable for high RPM operation. This is but it still retains the exact configuration of a Harry Miller Miller-Goosen engine, with the external cam carriers, the way the cams are driven, all the architecture. It has the characteristic look of the Harry Miller era, particularly from the 20s and 30s. And this perhaps may be one of the last engines built like this, because this engine was entirely hand built over the course of 7 years. All the patterns were done by hand, made out of wood. All the foundry work was done by hand with no automated processes. Everything was rammed up by hand. All the gates and sprues were cut by hand, and everything was machined by hand. As you can see, the machinery are all lathes and Bridgeports. There was no CNC involved in this engine whatsoever. Every single piece of this engine, every hole, every dimension was done by hand. The camshafts were made in that lathe and sent out to be ground. This was actually, it could be one of the last of the true hand-built engines. And we're very happy to show it to you. Not sure that you'll see the likes of these again. It's probably most reminiscent of the Miller V16 Marine racing engine. Of course, that engine raced against Packard V12s, but in the flathead configuration. This is what Harry Miller and Miller-Goosen would have done to the Packard flathead V12, given the opportunity to improve the design. So we thought you would enjoy taking a look at this, getting an appreciation for the valve angle evolution from wide to narrow over the decades and why that occurred. And I really hope that you enjoy the look of this engine. Hopefully it will be at the shows in a Packard within the next several years. So thank you.